Hi everyone, this is Mrs. Russell here. I am going to be going over how to solve linear quadratic systems algebraically today. This is section 0C.2 of your 0C packet, and I'm currently on page 8. So if you open up your packets, let's get started. So you see example 1, solve the system of equations algebraically. Now you're used to seeing two linear equations. Now we're working with one quadratic. When you see the x squared, that gives you a quadratic, and you have one linear. So we have a linear quadratic system. Notice they are both in y equals. So when you have equations in y equals in linear systems, you're thinking of substitution. So we're going to think of that exact same idea here. So first, we solve for one of the variables in the linear equation. So here's our linear equation, and this step is already done for us. So I have y equals 2x minus 2. Already solved for me. Next, we substitute that variable into the quadratic equation, and we solve the resulting equation. So for those of you who know my style, I like to circle the variable that I have isolated and underline what it equals. And I'm going to underline where I'm putting it in the other equation. So in my new equation, I'm going to have 2x minus 2 in place of the y. And the other side is going to stay the exact same, equals x squared minus x minus 6. So I have a little bit of info on the right-hand side here. Add 2 to both sides, subtract 2x from both sides. The reason I want to do this is because I can see this is a quadratic equation. So when you have a quadratic in here, you always want to move everything to the same side. And I always want to move everything to the side where I'm going to have a positive coefficient for x squared. So I'm going to subtract 2x from both sides. Notice I'm lining it up with like terms. So I'm not subtracting 2x from x squared. They're not like terms. I'm subtracting 2x from negative x. And I'm adding 2 to both sides. So I'm adding 2 to the negative 6. So from here, this whole side goes away. So I have 0 equals. X squared stays the same. And then I have minus 3x minus 4. Whenever you have a quadratic in standard form, now I'm looking to factor. So I'm going to factor by multiplying up, and I get negative 4. And I want to think of what multiplies to negative 4 and adds to negative 3. So I have 1 times 4 would give me 4, and 2 times 2. I need a positive and a negative to multiply to a negative number. And I'm going to use 1 and 4. I choose 4 to be negative because 1 minus 4 gives me negative 3. And I want to add to that middle value. So I'm going to split the negative 3x into 1x minus 4x. And then I just bring down the outside values. So x squared plus 1x minus 4x minus 4. The front two terms and the back two terms group together. I'm going to take x out of the front and negative 4 out of the back. So I have x times x plus 1 minus, I wrote 4, minus 1, minus 4, times x plus 1. So I call these my twins, x plus 1. They're the exact same. So then my two factors are x plus 1 and x minus 4. I need to move my work over here. X plus 1 and x minus 4. I can't forget it always equal to 0 at the beginning. I kind of dropped that when I factored, but it still equals 0. So now that I have my factored form, I'm going to set each factor equal to 0. The reason I'm going to set each factor equal to 0 is because this says x plus 1 times x minus 4 equals 0. The only way to multiply two values and get 0 is that if one of them is 0. So either x plus 1 equals 0 or x minus 4 equals 0. So then I'm going to subtract 1 from both sides here, and I get x equals -1. Or I'm going to add 4 to both sides here, and I get x equals 4. Now back in 0C.1, all we were doing is factoring and solving. This is not just factor and solve. So I had two equations. Thinking of systems, your solutions are x comma y. So I need to actually plug in these values in order to figure out what the corresponding y values are. So here it says, now that we have two values for x, we need to find the corresponding values for y. To find the y values, you substitute into the linear equation. So if y equals 2x minus 2, just like in the beginning, I'm plugging in 4. So y equals 4 was an x value, so I'm plugging it in here. 2 times 4 minus 2. So that makes y equal 8 minus 2. So y equals 6. So now, since I plugged in 4 and I got 6, the corresponding coordinate that is a solution is 4 comma 6. There it is. Now for the value of -1, I also need to find the y value. So y equals 2 times -1 minus 2. Y equals -2 minus 2. So y equals -4. So for this one, the value is -1 comma -4. Now I have two possible solutions, and I want to check them into each equation. So let's check 4 comma 6 in this equation, x squared minus x minus 6. So y is 6, x is 4, so 4 squared minus 4 minus 6. 4 squared is 16 minus 4 minus 6. So 16 minus 4 is 12, minus 6 is 6. 6 equals 6. Yes, that works. Let's check the other one. -4 equals -1 squared. Notice my parentheses. Minus -1 minus 6. So -1 squared is going to be 1. Remember, anything squared is positive. Minus -1 makes for +1, minus 6. 1 plus 1 is 2, minus 6 is -4. -4 equals -4. So when I write out my solution set, I write both ordered pairs. So since both of them checked out, both of them work, my solution set is 4 comma 6 and -1 comma -4. So I'm going to go ahead and open up Desmos and show you why this makes sense. So my equations were y equals x squared minus x minus 6 and y equals 2x minus 2. Notice I have my linear line and I have my quadratic. So here's 1 point, -1, -4. And here's another one, 4, where'd it go? 4,6. So that verifies graphically that I was correct in my algebraic solution. Having a visual sometimes solidifies that it makes sense.